this video, we're going to take a look at some of the exponent rules that you'll find in the algebra section and look at solving some or simplifying some expressions. The exponent rules that we have listed are the product rule, quotient rule, power rule, zero exponent rule, negative exponent rule, and expanded power rule. It's going to be helpful for you to familiarize yourself with these. And we'll give you some examples to show you how they work. If you forget the rule, always go back to what the definition is. You can see how it works based off of the definition. So for example, we'll start with the product rule. The product rule says if I have a base to a power and I'm multiplying with the same base to a different power, I'll keep that base and add my exponents. I'm going to show you why this works. So let's say we had x to the fourth power and I'm multiplying it with x to the third power. The rule tells me to go ahead and add my two exponents. So I would end up with x 4 plus 3, or 7, as my power. But what if I forgot the rule? Well, think about what that exponent means. It means I'm multiplying x with itself 4 times. Here's my 4 x's multiplied together. And then I'm multiplying it with x cubed, or x multiplied with itself 3 times. Here's my 3 x's multiplied together. We have that value x multiplied with itself a total of 7 times. So that's where that x to the 7th power comes from. You can do the same thing if you're working with the quotient rule. It says if you have the same base and they're being divided, you can subtract the exponents. So let's look at an example. Let's say I have b to the 4th power and I'm dividing it by b that's squared. Again, if you forget the rule, you can go ahead and go back to what your definition for an exponent is. I have the same base. B to the 4th means I'm multiplying b with itself 4 times. B squared means I'm multiplying b with itself twice. And if I use my idea of canceling factors that are alike, I'll notice I've got a b on top and bottom that disappear. And then I still have those two b's multiplied together, or b squared. If you use the rule, you'd be doing 4 minus 2, or getting 2 as the exponent. A power to a power works the same way. For the power rule, we just have a single base this time. It's being taken to a power, and then the whole group is taken to a power. Now again, the rule says you can multiply your two powers together. 2 times 3 should give me x to the 6th. But if you forget the rule, go back to what it means for that exponent. I have x squared, and I'm going to multiply it with itself 3 times. X squared times x squared times x squared. If you multiply it with itself 3 times, that means I'm going to go back and use that product rule, add my exponents up. 2 plus 2 plus 2 gives me x to the 6th. The same thing I'd get if I'd use multiplying these exponents. The zero power rule we've looked at before in the arithmetic section. It doesn't matter what you have in the group for parentheses, but if you take anything to the 0 power, you're going to end up with 1. I could have 7 multiplied with a 3x, multiplied with the y, or anything to a power, but if it's to the 0 exponent, it's going to equal 1. So if you've got that on there with the 0 exponent, it doesn't matter how messy it looks, it simplifies very well. The negative exponent rule we also looked at in the arithmetic section. Remember, the negative exponent is telling you to change locations. So if it's in the numerator, it'll go down to the denominator to become positive. Or if you have a negative in the denominator, it'll move up to the numerator to become positive. The expanded power rule works if you have several bases that are being taken to a power. Notice all the other ones that we've looked at, the bases have always been the same. And the way that these rules are written is so that you're talking about what's happening to the bases. Product rule means the bases are multiplied. Quotient rule means the bases are being divided. What happens to the exponents is not what the name of the rule is. The expanded power rule is the only one that has different bases. We have a base that's the value for the numerical part, 3. We have a base that's an x, and a different base that's a y. So it's pretty much like having 3 different bases in this problem. Again, these are being squared, so it's like it's being multiplied with itself. You can go back and use that definition of what an exponent is to solve it. Or what this rule is telling you is it's kind of like using the idea of distributing that exponent to each different base. So I'm going to end up with the 3 being squared, the x being squared, and the y being squared. Often they'll go ahead and actually with the number parts make the calculation, so 3 squared will give me 9, and you may see this on one of the multiple choice with 9x squared over y squared instead of the 3 squared for the numerical part. This gives you an explanation of how the rules work, and it's to your benefit to kind of be familiar with them, but again, if you're doing the test and you forget what the rules are, go back to the definition of an exponent in order to solve them. Most of the time, what you'll notice on the GRE is they're going to go ahead and just give you a problem that you have to simplify. You'll be using several of the different exponent rules together in order to do that. So here's our first examples. Notice I'm working with the base of b. I have a power to a power, and then I'm also multiplying these bases. When you go to simplify, I'm going to start by looking at using my power rule first. A power to a power means I'll multiply those together. So I end up with b to the 14 times b cubed. And so now I have a product rule I want to use because I'm multiplying those bases together. It tells me to add my exponents. So 14 plus 3 will give me b to the 17th power. Often it doesn't matter the direction you use those rules. You can pick whether you want to use one before you use another. Anytime you have powers going on, you will want to get rid of those parentheses first by using one of the power rules to start. The same thing's going to happen in our next example. This one we'll have a quotient rule being used because we do notice we're working with a base of p and it's being divided. But I'm going to start off again with that power to a power. So I'm going to want to simplify and get rid of the parentheses on top, multiply my exponents. So I end up with p to the 24 over p to the 8, and then use the quotient rule. I'll subtract my exponents, 24 minus 8. Make sure you take the top exponent and subtract the bottom exponent. And it should give me p to the 16. Let's look at some more. Here's our next one. You'll notice you see the base x, but we also notice we see it 3 times. For something to be simplified, when you get finished, you will only see the base once. So let's see what we can do to tackle this one. Again, I've got some parentheses, so we'll want to get rid of those first. I'll use the idea of taking a power to a power, and I'll multiply my exponents. So I end up with x squared times x to the 12th over x to the 5th. I'm going to use the product rule because I have 2 bases multiplied together. And I'll want to go ahead and add my exponents. 2 plus 12 will give me 14. So now I only have a single x in the numerator and a single x in the denominator. To finish, I'll want to use the quotient rule. Take the top exponent and subtract the bottom exponent. And I end up with x to the 9th power. Notice when we finished, we only see that base x once. We started, we had it in here 3 times. Let's take a look at some that may have some negative exponents. There's several different numerical parts. Here's our next example. When you're working with anything that has more than one part that's a numerical part, you can go ahead and combine those just like you normally would. When everything's stuck together, you're multiplying, and we don't actually have a power out here that we have to be worried with. So I can think about separating all of these and just multiplying them all together. I have 5 times 4, so I'm going to end up with 20. I have an x squared, and I'm multiplying it with an x to the negative 5th. I can go ahead and combine these 2 bases because they are the same. And it looks like I'll want to use my product rule. When the bases are multiplied, we add the exponents. So I have 2 plus negative 5, and it will give me x to the negative 3 power. Often you're not going to see them leave anything with a negative exponent. That's why they have the negative exponent rule. Since this is an x with a negative 3, that means to make it positive, I want to put it in the denominator. Now, only the negative 3 is on the x. It's not with the 20. So the only thing that's moving to the denominator is this value of x, not the 20. The 20 is going to stay up in the numerator, but the x is going to the denominator, and it's going to become positive. So I'll have 20 over x to the third. That'll typically be what you'll see on the GRE when you're looking for your answers. They won't leave them with the negative exponents. Here's our next example, and you're going to notice it has several parts as well. Some of them are going to be numerical parts. Some of them are with the base x, and some of them are with the base y. So you want to kind of separate them out. I can simplify 2 over 8. 2 will go into each as a factor. It goes into itself once and into 8 4 times. And then I'm going to want to use the rules that I have for my exponents. I have x squared and x to the 7th. So if I look at working with the x's and take 2 minus 7, for my x's, I'm going to end up with a negative 5. Do the same idea with your y's. Again, I have a number on top, and I'm going to want to subtract the exponent on the bottom. Be careful with the negative signs. We have a 5 minus a negative 3. So for my y's, it's going to give me y to the 8th. And I have that fraction 1/4 out front. The 1/4 is like setting that up as a numerator and denominator. We have the 1 on top, but notice we also have a y to the 8th. It's positive. It'll go on top. The 4 is in the denominator, but notice you also have a negative exponent, x to the negative 5th. So to make it positive, I'm going to need to put it down in the denominator and change it to a positive exponent. For this problem, when you're looking for it for your solution, they probably won't put the 1 in the answer. You'll just see y to the 8th on top and 4x to the 5th on the bottom. Our next example has an entire group inside the parentheses being taken to a negative exponent. I'm going to start this one by going ahead and using the idea of distributing that exponent to each base that I have inside my parentheses. The 2 is a base, the x and the y. Don't forget the number parts. They also are considered bases. I'll have 2 to the negative 2 power, x to the negative 1, which I'll take to the negative 2 power, and y to the 5th, which I'm going to take to the negative 2 power. Again, I've got a power to a power, so I'm going to multiply these together. So that'll give me x squared. And for my y's, negative 10. And 2 to the negative 2 power. Now, some of these are positive exponents, and some of them are negative exponents. The positive exponents I'm going to leave in the top. That's my x squared in the numerator. And anything that has a negative exponent, I'm going to move down to the denominator to make it positive for my exponent. So I'll have a 2 squared and a y to the 10th. Again, they probably won't leave the 2 being squared. They'll go ahead and actually square the 2. So you typically see this as an x squared on top and a 4y to the 10th on the bottom in the answer section. Here's our last examples. We have a base, and it's the 4. There isn't even a variable in this expression. I still am going to use the power to a power and multiply my exponents. So I'll have 4 to the negative 6 power. Now you're not going to want to leave that negative exponent. It's going to need to be positive, so I'm going to want to put it in the denominator. I'll write it as 1 over 4 to the 6th power and change it from a negative to a positive 6. Again, they typically won't leave this 4 with the exponent on it, and they'll probably go ahead and work it out. Remember, you're multiplying 4 with itself 6 times. So you may see 1 over that value in the denominator instead. Because 4 was our only base, they may actually leave it as 1 over 4 to the 6th. So you just have to check the answers to see which one you're looking for in the multiple choice section. And here's our last one. Again, I've got several different bases, and I'm taking them all to the third power. It's outside of those parentheses. So I'm going to need to distribute it with each base that I have inside. That means the x is going to get that exponent of 3. The y to the negative 2 power is going to get the exponent of 3. And the z on the bottom is going to get that exponent of 3. I still have one I want to simplify. Even though I see each of the bases once, I do have a power to a power. So I'll want to multiply those together. So I end up with y to the negative 6 power. And since I have a negative exponent, I'm not going to leave it. I'm going to go ahead and change it and move it to the denominator to make it positive. So the only thing we'll still have left in the numerator will be the x cubed. I'll move the y to the 6 to the bottom to become positive, and I'll still have the z to the third in the denominator as well. Hopefully you see how you can use several of the rules together to simplify some of your problems, whether you need to use the power rule, the quotient rule, or the product rule. Any of those can be used in combination with any of the others to simplify any of these exponential problems.